Okay, so where we left off in part 1 was that we solved for x, right? We knew that the sum of the pentagon, the angles, was 540. We added all of our angles up together to get 26x plus 20 and solve for x. So if I were to go through and find the measure of each interior angle, well then I would just need to be plugging in x for each. So if I start with the measure of angle A, 4x plus 10, well x is 20, so 4 times 20 is 80 plus 10, that's 90 degrees. Then if I go to B right here, 6x plus 10, 6 times 20 is going to be 120 plus 10, that's 130. Okay, and then I'm just going to do this for the rest of my angles. I want to go in alphabetical order like the polygon name. Okay, A, B, C, D, E. C is 5x minus 5, so 5 times 20 is 100 minus 5, that's 95 for C. D, 4 times 20, 80 plus 5, that's 85 degrees. And then C, 7 times 20 is 140 degrees. Okay, so clearly it's not a regular figure, but like I said, we will definitely clarify in your question if it's regular or not. Okay, so question like 3. Find the measure of an interior angle of each regular, there it is, regular polygon. Round to the nearest tenth if necessary. Okay, an interior angle, meaning just one. So we still need to figure out, well, what is the sum? That's our 180 times n minus 2. And if it's regular and I just want to find 1, I would divide it by n. Okay, that's kind of a rule for that. We can actually put that in our table on page 1. Forgot to mention that. So I would take my sum, 180 times n minus 2, divide it by n, and this is only for regular polygons. Okay, so if I have an octagon, that means n is equal to 8. Okay, my sum would be 180 times n minus 2, so 8 minus 2 or 6. My sum of an octagon is 1080, but I'm going to divide it by n. So divide it by 8, I get 135 degrees for one interior angle of a regular octagon. For a decagon, that is going to be 10 sides. Okay, we have to know this from our table. Decagon is 10. 180 times 10 minus 2 divided by 10. So that's going to be 180 times 8 divided by 10. I get 144. Okay, so on this question, it says the measure of an interior angle, that means 1, of a regular polygon is given. So here's the measure of one interior angle. Now we're finding the number of sides, which is n. Okay, so this little formula that we wrote, what I'm going to do is I'm going to take it, 180 times n minus 2 divided by n, and I'm going to set it equal to that one interior angle. Now I have to work through this formula to solve for n. So in order for me to get rid of this denominator, I'm going to multiply both sides by that denominator, which is just n, and it's going to cancel it out over here. And I have 180 times n minus 2 is equal to 108 times n, or 108n. Now I have to distribute the 180, so 180n minus 360 is equal to 108n. When you have a question like this, here's your shortcut. Just start right here. Because every time you do this type of problem, these first two steps is going to be the same. What you need to do, though, is just make sure you multiply your angle by n on the right. But every time I do this type of problem, I'm going to land with this on the left side. 180n minus 360 is equal to your angle, right, times n. Okay? I need to get my n's on one side, so I'm going to subtract over 180n from each side. That gets me negative 360 is equal to 108n minus 180n, or negative 72 in. I'm going to divide by negative 72 to get just in, right? If we're talking about number of sides, it should be a positive, okay? So negative 360 divided by negative 72 would be equal to 5. Okay, so that is the longer way of doing it, which I will show you a shortcut of this type of problem after we kind of talk about exterior angles. But if you based on the rule, you would set the rule of one interior angle equal to that angle. And like I said, this is going to be the same every single time. So you can just start here when you're solving. Okay, so now let's look at these figures below. It says, look at each pair of adjacent, remember adjacent means next to each other, adjacent numbered angles, such as 1 and 2, right? 1 and 2, or 11 and 12. Okay, or it could even be like 15 and 16. Two angles that are next to each other, 33 and 34. What is the relationship between the two angles? Okay, we know this from chapter 1. Any two angles right next to each other that form a straight line. Okay, these are forming a straight line. These two are forming a straight line. These two are forming a straight line. And so are these. They are linear pairs, meaning they add to 180 degrees. Okay, so what you need to know is that for any polygon, right, one of the interior angles plus one of the exterior angles, right, the adjacent interior plus the adjacent exterior are going to add to 180. So going back to this problem, okay, I know that if here's my interior angle, well, the exterior angle had to be 72, right? That exterior angle, 108 is the interior. The exterior has to add to 180, so it's 72. Okay. Now, we have the exterior angle sum theorem. Okay, our interior angle sum theorem was 180 times n minus 2, right? That only applies to interior. The sum of the exterior measures of a convex polygon is always 360 degrees, no matter what. It does not matter how many sides there are. You could have 1,000,000 sides, and all of the exterior angles add to 360. So, remember, your number of sides is equivalent to the number of angles that you have, whether they are interior or exterior. So back here, if I want to find the number of sides and I'm given an interior angle, figure out what the exterior angle is, right? 180 minus the interior. Take your sum of exterior angles and divide it by that exterior angle, 360 divided by 72, I get 5, which is what we did over here too. We just did it the formal, longer way using our rule. Okay, but what we know is that any polygon, the sum of the exterior angles is going to be 360. Your number of sides is equal to the number of interior angles and the number of exterior angles that your figure has. So use the shortcut. Okay, I'll show you a couple more examples. Number 5, find the measure of each exterior angle. We know that they all add to 360, no matter the number of sides. So if I take 6x plus 9x plus 2x plus 139, it's going to total to 360 degrees. If I simplify this, 6 plus 9 plus 2, I get 17x plus 139 is equal to 360. When I subtract over 139, I get 17x is equal to 221. Divide by 17, and x is equal to 13, okay? They want to know the angles, so I'm just going to plug in 13 to my figure. Here's 139, right? 6 times 13. All right, if I take 6 times 13, I get 78. So this angle over here is 78. If I take 2 times 13, this angle right here would be 26. 9 times 13, I would get 117 degrees. Okay, so 9 times 13, 117. Okay, so all the angles, the exterior angles, add to 360. Okay, find the measure of each exterior angle in a regular, so all the exterior angles are going to be the same, 18gon. Okay, I don't have to draw this. I don't need to know any kind of rule. I just need to remember that the sum of the exterior angles is 360. And if it's a regular 18gon, then they are all going to be the same. So I'm just dividing 360 by that number of exterior angles. So 360 divided by 18, I get 20 degrees. Okay, and knowing that exterior angles and interior angles form a linear pair, all right, each interior angle would be, if this is 20 degrees, this would be 160 degrees. Okay, because 160 plus 20 equals 180. All right, if I wanted to verify, I could use my rule, right? If it's 18 sides, the sum of 18 angles would be 180 times 16 divided by 18 interior angles, 160 degrees. Okay, so your exterior angles are kind of a shortcut to these rules. All right, so tonight's homework is a 6.1 worksheet on just page 10. Okay, make sure you submit your answers into Canvas by Thursday at the end of the day.